So we have a student on one end of a raft floating in a pool with equally spaced marks on the bottom. The raft and the student have the same mass. And the student walks to the opposite end of the raft, and we're asked to depict what that would look like. Or choose the correct one. So first of all, what we know is that the student is going to walk in this direction. We have initial momentum of 0. And so when the student gains momentum in this direction, the raft is going to gain momentum in that direction. And so what we know then is that the center of mass of this system must remain in the same place. So if we pick the center of mass of the person, let's say it's there, and the center of mass of the raft is there, the overall center of mass of the system is going to be right there because they have equal mass. Now, if you notice, the center of mass of the system is about the midway mark between those two. Now, when we look at this other one, now we have the center of mass like so, center of mass. We find the new center of mass. It is nowhere near here. So choice A is out. Using the center of mass again, we have here and here. Center of mass is here. Again, nowhere near here where it needs to be. This next one, center of mass here and here. And there's the center of mass. And that looks like it's right where it needs to be. Choice C. Let's go a little further. Choice D, center of mass, center of mass. Way to the left of where it should be, so it's choice C. This is not the intuitive way to go about doing this, but it is the easiest way to go about solving this. The other way we can think about this, though, however, is to think about this from the momentum and the velocity. So if we have a change in momentum, the change in momenta of each body must be equal. The delta P of the student must equal and be opposite to the change in momentum of the raft. And so this is M delta V, and this is M delta V. Now, the masses are the same. So since the masses are the same, the delta V of the student must be equal and opposite to the change in velocity of the raft. So in 1 unit of time, if the person moves this far, the raft will move in the other direction the same distance. They will both travel the same distance in the same amount of time. So we could make a comparison to see how far it moved. So if the person walked and changed by this amount and the person is now here, then the raft should be about here, like so. So we look at those choices. The person was originally at the 2 mark. They were both edges were at the 2 mark. So, and the raft was originally here like this. You can see that the person who was here moved a distance of 1, and the raft moved a distance that way of 1. So they each moved an equal distance.